How's everyone enjoying your time so far here? All right. Good. We're almost at the end. Don't worry. But this is the most exciting talk of the day. Hi, everyone. I'm Itamar. I'm very excited to present the wild world of error handling in GraphQL and to talk about how the landscape of error handling in GraphQL is changing these days. Just a precursor, this is very heavily JavaScript coded, but the features I'll be talking about are easily translatable to any other language, and there are actually other clients that are already implementing similar things. Also, I didn't expect the room to be this long, so I do have a bunch of code examples. I am so sorry, everyone. If you want, you can just move forward and squint. All right, awesome. So on our journey, you can expect us to cover how error handling works now, why it's less than ideal, and how throw-on field error and the @catch directive can make your lives much easier. Finally, I'll leave some time for questions and answers at the end. So a bit about me. I'm Itamar Kestenbaum. I work at Meta in Infrastructure Experiences, or InfraX. And I'm an honorary member of the Relay team. Before we dive into the GraphQL spec and all kinds of examples, let's start with a simple example of GraphQL schema and some baseline issues we've probably all dealt with. So this is the example we'll be coming back to periodically during this talk. We have a response type, which represents the data constant over here. We have a user type that can have a name, a pet, and a best friend. Users must have a name and a best friend, but not all users have pets, sadly. So that means that name and best friend are non-nullable, and pet can be null. Pets have all non-nullable name, kind, and breed, but that's less important. We'll be altering the query from example to example, but there's a good starter example, and that's what we're going to be using. You're probably familiar with needing to treat both me and best friend as possibly null in your query anyway, even though they're non-nullable. But why? Both of them are semantically non-nullable, and you should be able to access them directly. If they're null, that should mean that something's wrong. But that's just not how GraphQL clients have worked until now. We'll get into why in a bit. Let's take a slightly more sensitive example, a bank account, right? Just like in the previous example, even though semantically balance is non-nullable, GraphQL clients still type it as null because of the possibility of an error state. However, to please the linting and type system gods, our engineer decides to cast the value to a number so that it meets the typings of the properties for this specific component, and that removes the type incompatibility. What could possibly go wrong? However, JavaScript is super chill and flexible and terrifying, and casting nulls results in unintended consequences. So going back to this example, you can see that while the value was unexpectedly null, the engineer introduced a bug where the account balance shows a 0, which can be scary if you're a human who likes to have money in their bank account. If you think that's a far-fetched example, I thought it would take me a while to find, of Googling, like to find an example of this, but it took me less than a minute to find this. And here we are. I hope you can tell from the post that this is distressing. The user is really shocked, and they tried to get the attention of the company, of the bank that showed them the 0. Now, I don't know if this UI is in JavaScript or not, but clearly coercion of values presents this problem, and having nulls all over the place in your application are a gateway to that. So how do we get to such an imperfect state in error handling in GraphQL? To understand that, we need to go back to GraphQL spec and understand what's actually expected of GraphQL clients. So let's do our favorite thing and look at the spec. So you don't have to read this entire thing. But essentially, when errors occur, a GraphQL server responds with the partial data it was able to execute and resolve, and an array of errors with details on the cause of the exception. The error entry also has to include a path to the error that occurred. This way, a null value in the payload can be ascertained to be a true null or a null that resulted from an error, based on the existence of that field in the errors array. Simple, right? In practice, however, GraphQL clients have not been doing this at all. Instead, engineers using GraphQL clients have been left handling possible null fields, even in cases where null is not really possible in an error state. Even if a field is nullable, an engineer still couldn't be sure whether that null is due to an error or a true null result. So this leads to the infamous optional chaining pattern you've been using in your components to indicate if something is null, display something else, even if the fields are semantically null. So to answer the question, how did we get to such an imperfect state? The answer is simply most clients haven't gotten to it yet. So to recap the pitfalls of error handling so far, we have this, non-nullables being nullable anyway, because why not? Then we have the ambiguity of a null value, not knowing if it comes from an error or if it's truly null. We have all these extra nullable values in your application, which are, as we said, a gateway to very bad, no good bugs. And on top of that all, the errors are being provided by GraphQL server, but we've been ignoring them until now. So they're there, we're just not using them. So let's stop complaining, I'm talking to myself, and talk about how we can fix this. In come the dynamic duo of throwing field errors by default, coupled with the new @catch directive to allow inline catching at render time. First, let's talk about throw on field error. When we get a null value that has a corresponding error, or if data is missing that's expected, we throw a JavaScript exception, something that most engineers expect to happen and just wasn't the behavior. Error boundaries can handle those, as usual. And you can also supply a shape for your error that you're expecting from the server side as a type. So you can actually bring your own error type and handle it much more granularly. Again, this example, you don't have to read it, but it's an error boundary that should look familiar to a lot of people. Here we have a very standard error boundary, but there are two new capabilities that throwing on field errors unlocks. The first is that you can use error boundaries to catch field level errors, which was not the case beforehand. Now, with fields themselves throwing, you can predictably control how you handle errors on a more granular level. The second is that field level exceptions were previously silent, remember? Just giving you a null to deal with. Beforehand, you had to create an elaborate custom contract with the server to indicate if something went wrong or right. This error or data, stuff like that, this error boundary uses the previously hidden errors to make a significant change in the behavior of the application based on the expected exception types. In order to solve the first issue of non-nullable fields still being not nullable type, we need a way to ensure that a field can never be null, right? Because that was the problem originally. Clients can do this by throwing an actual JavaScript exception if that field has an error on it. So that way it cannot be null. So let's take this example from before. Here you can see that all three, me, best friend, and name, are all non-nullable, meaning we shouldn't have to handle their null state if they're returned successfully. Now that an error would result in actual thrown JavaScript exception, you're left only needing to handle the data as is intended instead of dealing with hypothetical nulls. Can people see this okay? Do I need to describe what it? OK. I ask halfway through. For fields that are nullable, we want to know that the value is not null because of an exception. Throwing by default allows you to make that distinction implicitly. Here's an example of that. here you can see that, remember, pet was non-nullable, right? Here you can see that me is non-nullable. Pet is nullable because you don't necessarily have a pet. And name is non-nullable because each pet has a name. We should expect that we will have much more confidence in the state of a null pet as indicating no pet at all, now that the error state cannot exist there, right? So if a pet doesn't exist, instead of giving you a null that you don't know what it means, it'll just throw a JavaScript exception. So this solves both the non-nullable and the nullable case. And indeed, that's the case. You can see that while handling the data is almost exactly the same, two new things are happening here. You're now 100% confident that the pet is null, that if the pet is null, there's no pet, and not that something went wrong. If the server found the pet but had trouble fetching the name, you still wouldn't end up at least at the last line of this component. Rather, you'd hit an error boundary. So there's no risk of finding a pet and trying to render, only to have a null name, which you don't want, I guess, unless your pet's name is null. Which, like, what are the chances? I have to remember that's going to be my next pet's name. No, it's kind of mean. I don't know. So you might say, wait, Itamar, it's great that we're throwing field-level exceptions, errors now, but I don't want my components to just be thrown away every time a field throws an exception. If you think about it, adding field-level exceptions kind of multiplies the chances that you'll have an exception in your component. So what do we do about that? In comes the catch directive to complete the error handling experience. I did have an image that I generated with Meta AI that actually was like an action movie poster that said the catch directive. And I thought that was really clever, but it didn't make it. So the catch directive lets the error in runtime without the entire, lets you get the error in runtime without the entire component being thrown out. Let's look at how this works. The best friend or name throw an exception in execution time on the server. Their errors will not be thrown by the client. Instead, they'll be provided inline at best friend level, where the catch directive is. The response type for a catch directive field looks like this, with a union of either OK true with the given semantic value associated with it, or OK false with an array of errors from the server side. The reason for the array of errors is because GraphQL can return multiple errors on a field if several methods through. It's even composable in that you can tell the client what your errors type should look like, so when you're handling errors, you can retain type safety. With the ability to tell if a field is in an error state or not, you can easily update how a component will render without having to throw the entire query away. Engineers can also eliminate the need for a custom contract between the server and client, where a field can be in an error state or value state, since clients can provide it out of the box. So you no longer have to say is error or something like that. Right? Can everyone see we have a catch over here? And that means that, that if an exception is thrown, best friend will have OK. Sorry, it will always have OK. But if it actually threw an exception, it will be OK will be false. And you can handle that case without throwing your component away. Remember, pet is nullable and has a catch on it. Here, we can differentiate an OK pet from non-OK pet and know for sure if a pet is OK and its value is null. That means that all is well and that there's just no pet. If we reach the last line here, we're confident that something went wrong. If we wanted to, we can also reach into the pet.errors array and see what happened. An even more powerful advantage to this feature is that you can fail smaller, and that you can provide, and that you can choose to display the fields that executed correctly while handling errors on fields that didn't. So that's very, very powerful. Yeah, so some frequently asked questions. This looks wildly like Q&A, so I was like really, really confused for a second. How does required work with this? You shouldn't need to reach for required too much if you're using these features, since throw on field error with non-nullables give you the same behavior. If you do have a required field with a throw action, it'll behave just like a server-provided error, the same expected behavior of being caught at a higher level or at the same level if it has a higher level. Sorry. Clients can also now can also allow engineers to upgrade using these tools by providing feature flags and query-level directives, so they can incrementally improve their app without having to flip a switch for the entire thing. We heard a couple of talks today of people talking about very carefully upgrading their app or migrating it over to different technologies. And I think that giving the tools for people to do this safely is critical for adoption. So once most or all of the app is treated with throw on field error, an app-wide flag can be turned on to make that behavior the default. And then you're done. Lastly, @catch can be used with or without throwing enabled, which gives users extra flexibility. Also, there's an @catch to null option, which basically reverts all behavior for that field to previous behavior. So if you're not ready to deal with a field for some reason, but you do want to put a throw error on field, you can just put the to null on there, and you'll still retain the exact same behavior from before, while all the other fields will get the new behavior. So when can you use @catch and @throw on field error? These features are already shipped and available in Relay's newest version, 18.0, and is being adopted by other GraphQL clients as well. We'd love to hear your feedback on these features. Thanks. I imagine this was super clear and no one has any questions. Yes?
First question is for the catch directive. It feels like you wouldn't necessarily want that only on specific fields. You'd end up just wanting it on all fields. Is there like a @catch on all my individual fields?
No, we don't have an option to just say, OK, for this query or fragment, give me @catch behavior on everything, although that's a cool idea. I think that @catch can be thought of as almost like a JavaScript catch, right? So anything below in the call stack that throws will be caught by that. So I think the example of the pet is a good one, right? We're talking about what if pet is fine, right, and doesn't have an error on it, but name fails, and that's what you're trying to display, right? So you kind of need to be strategic about where you place the @catch. It's possible that you might put it on every field, but I think that might point to, I think it would be a little bit of overload at that point. You probably want to just think, OK, what do I want to display? And what do I not want to display if something throws, and then handle it like that. Does that make sense? OK. Yes?
Is catch going to work on alias inline fragments?
Wow. What a great question. I was going to throw it to Jordan, but he already caught it. Perfect. Other questions, please. Yes?
I'm a little bit confused about when we should use required versus the throw on field one. To me, kind of it seems like they're the same.
Yes.
Yeah. In one case, would I use one more than the other?
Yeah. So you're exactly right about that. So required action throw is like a subset of the catch behavior, right? So as I mentioned beforehand, if you have a non-nullable field, right, with throw on field error, then you have the required behavior, right? So that's why I said that eventually you might want to switch those out, when you're ready to do so. Yeah. And at the same time, we made sure that required still played nicely with catch if you have it below, right? Yeah. Yes, in front, and then we'll go to the back.
Yeah, so I'm not that familiar with relay, but do you normally have to deal with like an error object on your user query book? And like, is that why like the catch and draw are useful? Is like, how does that drive like the mobile? I apologize.
No. I'm struggling to hear you. Do you want to use the microphone?
Sure.
Or just speak up? It's okay.
So I'm not that familiar with relay.
Mm-hmm.
When you call the user query book, when you have in your examples,
Uh-huh.
is there normally not like an error property on that constant that you get? Like, is that why these directives are useful? Or?
Yeah. So the good question. The question was like, is there not like some sort of like if an error occurs, here's a callback or something, right?
Yes.
So first of all, I used that hook as an example. I wanted this to be, except for the last slide, I wanted it to be fairly agnostic to framework. So the answer is that like no, there isn't usually that. The exception is in mutations for some reason, but there isn't a callback on queries if there's an error. Do this. We did consider that for a moment, but we decided to stick with the same pattern as other directives have, and like bake it into the query. That said, that's a really good question though. Also because we've been thinking about possibly creating some sort of error resolver to allow that functionality, but we're still thinking about that. Yes, sorry.
First question, so seriously excited about this. When are you going to enable this function?
So, yeah, so it's in Relay. It's already available. We shipped it last week. Super exciting. We worked on it for a long time, and it's available in the new version. So if you upgrade to version 18, you should have it. Second question. You had two questions, right?
I saw your mention non-exposed error message and versus I think there's the exposed error message. Do you have any features to like enable exposed error message? I think by default they're all like non-exposed.
Are we? Sorry. What error is not exposed?
Non-exposed error message in the data at the very top, I think.
Throw on field error?
Yeah.
OK, so I don't know if this answers the question, but hopefully it does. The reason why we went with throw on field error and also having a flag for your application is because we want to give the flexibility to incrementally adopt it, right, on a query level. So if you don't have one of those two enabled, you won't get the error handling functionality that we talked about today. Does that answer the question?
Yeah.
OK. Great. Other questions? Yes, sorry.
Yeah, so I'm just looking at a couple of slides with the code examples with app catch. Maybe you can help kind of move it back. And
Yeah.
I guess my question is mostly on the couple more ahead, where you have the .ok and dot.
Oh, OK. Let me find that.
Yeah. So any of these would work. And basically, my question is like kind of user developer friendliness. Maybe I'm misunderstanding it, but it looks like you kind of are expecting people to first do the OK check. Then like they can decide if I want to access value or if I want to access the errors. But there's nothing preventing an engineer just to forget about this and just check best friend of value without checking best friend of OK. Right? How do you address that? Is
Yeah.
that a valid concern?
Yeah, that's a totally valid concern. So we thought about this a lot, and we actually did a lot of interviews, like in excess of interviews with engineers to make sure that the ergonomics were correct, because this is kind of a hard thing to solve ergonomically. But I think the best answer to your question is that if the reason it's a union is because dot value won't exist on pet if it's an error, if OK is false.
So like TypeScript and Flow will not let you access that value field unless you've asserted that OK is
Yeah, you have to kind of
Okay.
get that out before you can handle it. Yeah. Yes.
If multiple fields underneath pet error out, do we get like a single error, or do we get like an array of errors? Like, what's the behavior with multiple field error?
Yeah, so the reason that errors is an array is for that reason. So you can imagine the tree of child fields, and if multiple of them error, then the client will collect those errors in the store and then provide them. One more thing. For those familiar with the Relay store, this does not augment the Relay store in any way. The Relay store does not change with this new behavior. Yes, and then we're good on time.
just like, from my understanding, adding the catch on the best friend and pet, like basically puts like the .ok and .value properties on like those fields.
Mm-hmm.
But I'm just wondering for the throw on field error, in what scenarios exactly, like this toy example, would we be throwing in data scenarios?
So if me errors, you'll throw, right? But anything below best friend and below, including best friend itself and pet and the pet's name, will be caught. So it also includes the field that the directive is on. Yeah. Yes.
I know the semantic non-null is still being proposed. It's not finalized yet. But how does this play? Does it play friendly with that, or is it going to be like once that's implemented, that'll be a replacement and alternative for this, or will they kind of work together?
So they work together. This is the title of the talk kind of addresses that also, in that this paves the way to that. So this is kind of like, even though semantic nullability is not yet settled completely as to exactly what it'll look like in the syntax, for example. It doesn't change. Like, everyone agrees on that this is the way it's supposed to be in practice. So this is an example of how you can, as a client, as a GraphQL client, any GraphQL client, implement like something that's compliant with a semantic nullability when it becomes canon. Yeah. Sorry. Yeah.
Those relays for the error when it like throw it every time the fragment reads.
Yeah, I mean, the fragment's not going to read again because the component is thrown out.
I mean, imagine there are several components that access the same fragment and render at different times,
Mm-hmm.
and that those components to refer to a single query, and that errors,
Mm-hmm.
and each of the component throws its own errors, right?
Right. Yes. And we err on the side of consistency for now. There's a little bit of a debate on data consistency versus having components kind of reflect the result of their own fetch. But since we have a store that supports data consistency, an error will exist on that path, and then will be displayed.
So,
Yeah. Unless you're accessing it in some other way.
so relays storing the error, right?
Yeah. We added an error try to the store that holds the errors when they occur. Yeah. Awesome. Yeah. Last one. Yeah.
So I can see this working with like field level errors that are sort of not part of the schema.
Mhm.
But other folks might type like the get best friend as a union of like, okay, we have a best friend, or this errored out. Is there any plans to make these directives work with essentially like refining to the okay type in a union in a situation like that?
I'm not understanding the distinction between this and
So you
what
have
you.
like a best friend and it might just throw, and it is semantically not null.
Yes.
If you
Okay.
But it's semantically not null.
Okay.
You might also have modeled that in your schema as like a union of we have a mean,
Mm-hmm.
or there was some transient network error and we didn't get the mean.
Okay.
Is there any thought about making these directives work with unions so as to like essentially be a refined to the OK type? It says like throw on field error being a refined to the OK type.
We don't have plans for that at the moment. It seems like you either have one or the other. Like if you have one, you probably won't need the other. So if they both exist, then you're maybe not ready to throw on field error. Okay. Thank you so much. If anyone has any other questions, feel free to ask me after.